Thank you everyone for making time to join us today, and welcome to part 2 of our webinar series, where we are diving into how we can reach the bottom of the pyramid by investing in housing solutions that really work for the low income earners. When we held the first part of the webinar series in March of this year, we had focused on the housing chronicles in Huruma, informal settlement upgrading, with a specific focus on the construction cost tracking. And the main objective back in March was to support realistic investment planning for the ghetto informal settlement upgrading program by providing financiers with accurate construction cost estimates based on current pricing and community-driven practices. As you might have seen in the marketing poster that we shared for today's webinar, we will be diving deeper into the topic of exploring new builds for very low income earners, with a special focus on the ground +4 block typologies. Today's session is all about sharing insights from a recent study that looked into how we can design housing that is not just affordable and scalable, but also practical and livable for the low-income earners. We will talk about practical designs that strike a balance between density, cost efficiency, and the needs of the very communities that we serve. The findings are geared towards investors, developers, and policymakers looking to support scalable solutions in the affordable housing space. My name is Patrick Masharia, and I serve as the Affordable Housing Finance Specialist at FSD Kenya. And this afternoon, I'm joined by a host of key stakeholders in the affordable housing space, whom we collaborated on in this study to develop these ground +4 typologies that will be the focus of today's discussion. As we discuss this agenda today, we'll be hearing from architect Nicole Mutai from Grasp Design, who will be sharing the architectural aspects of the typologies. We'll also hear from Brian Otieno from EULA Engineering and Construction, who will take us through the structural aspects of the typologies. We'll also get to hear from QS Jeff Nyamori of Getso Consultants, and he'll be breaking down the cost components of the typologies for us to get a better feel of what it would take to bring these projects, these typologies to completion. We'll also hear from Michelle and Alan of CAF, who will jointly guide us on the implementation of the feasibility that led to the outputs that we will be discussing during this session. In addition, we'll also have a fireside chat featuring organizations that play in the housing space, and these will be Leaf, Real, and UN Habitat. And from this, we will hope to get insights on how these typologies can also be enhanced to drive the desired outcomes for all the stakeholders involved. As we move to the second slide, you'll appreciate that these outputs were meant to share the results through collaborative efforts that brought together multiple partners who are FSD Kenya, which is Financial Sector Deepening Kenya. And this is an independent trust that has an affordable housing project work stream, one of them being the informal settlements. Another key partner is the Livelihood Impact Fund, LIF, and this is a USA-based fund that seeks to meaningfully improve the lives of the global poor. We also have the Center for Affordable Housing, which is CAF, and this is an independent think tank advancing housing markets across Africa, supporting investment and policy decisions for affordable housing through research and data. We also have Grasp Design Limited, which is a registered architectural firm that aims to continuously innovate for the evolving needs of communities through architecture, master planning, and interior design. The other key stakeholder is EULA Engineering and Construction, which is a medium-sized consulting engineering and construction firm with the capacity and expertise to effectively deliver civil and structural engineering solutions on a variety of skills. We also have Getso Consultants as a key stakeholder in this engagement. And Getso is a cost consultant that provides clients with strategies for cost and project management, design and build projects, as well as alternative dispute resolution for construction projects. Of course, the other key stakeholders would be players in the affordable housing space, namely UN Habitat, which is the UN arm that promotes transformative change in cities and human settlements through knowledge, policy advice, technical assistance, and collaborative action. And of course, we have REAL, which is an innovator and an investor in climate-smart affordable homes in urban Africa and Asia. And to start us off, I'll want to invite architect Nicole Mutai of Grasp Design to take us through the architectural part of the G+4 typologies for us to appreciate how these designs were conceptualized, even as we progress. So Nicole, you may proceed when you're ready.
Okay, thank you, Patrick. I think we're glad to be here and taking part in this discussion. So I'll be taking us through the architectural aspects of the G+4 typologies. So I'm about to share 3 major typologies, 2 of which is what is currently being built in Kenya, and 1 which is sort of new to the market. So before I do that, what we considered as we were designing this affordable housing scheme was 1, the socio-economic aspect, socio-cultural, and then the environmental impact of what the project would do. So on your screen is what some of our design highlights that are featured in this project. So the first big materials and resources. So here we were going for very low maintenance, very low embodied energy materials. We're looking into okay, since these are basically medium-rise buildings, we're looking into load-bearing wall systems as opposed to columns and beams system, which eliminates the cost of structure, which significantly brings down the cost of whatever we're trying to do. So these are framed construction systems, which as we're going to see, we're having all the walls line up such that the load is bared by the walls as it suggests. Also going to source the labor locally. I think here I should mention we're looking into materials fairly new to the market, including twist blocks. These are the concrete blocks that are, you literally stack them up like Legos. So this even eliminates the cost of finishing because it's fair-faced, and even mortar because you just literally stack up the blocks. So we're looking into such kind of materials to just bring down the cost and also involve the community, as these are the people who are going to be trained to, build at the place where the site is going to be. So other than that, we're also stacking all our wet areas. This makes all the piping systems so efficient such that you can share pipes between units. While also minimizing the cost of finishes, since, as you will see in the next typology, since we're sharing the wet area, we're going to minimize the cost of finishes per unit. So other than the materials, we're looking at the indoor air quality and environmental quality. So here we're using central courtyards. This will allow cross-ventilation into all the rooms. Because as we saw in some of the studies that we did for this project, a lot of the developments were very double banked. There's only one source of air, and that is through the door, and no windows. So we're trying to improve what is currently on site, currently being done in some of these areas. We also it was a big issue for us was the community aspect. So here we introduced shared facilities such as a communal playing area on ground floor. We also have communal vegetable gardens, shared wet areas, shared social spaces on the rooftops. So, and then just to add an extra layer of efficiency, we wanted to incorporate some water saving aspects, such as now in terms of the finish, the fittings, the taps, the toilets. So we're going to have water leak detection systems, water saving toilets that were spec'd. We're going to collect rainwater from all the units so that these may be used now as water just to use even for irrigation, for cleaning, and such kind of things. So without further ado, we'll go to the first typology. So this is we call it the social housing typology. So here, the key aspect was just to have one communal wet area. This is now for the showers and the toilets, as well as the dobbies. So for these, we were calling them one-room units. So these were fairly small, with a net area of about 10 meters squared. And for this typology, for each floor, we had about 26 units per floor. So each sharing about 6 showers and bathrooms. So that's a ratio of about 1:4, which is a big improvement from what we saw from some of these case studies that we saw. So the rooms typically, they would just have a bed, a closet area, and a counter where they can cook and do. So we're supplying water to each unit for now the cooking aspects. But ideally, they're all sharing this central wet area. So as you can see, all the walls, okay, as I mentioned before, we're doing a framed structure with load-bearing walls. What this means is that all the columns are essentially being eliminated from the design, apart from on the circulation cause. So as you can see, it's a typical floor. So all the walls line up so that they essentially bear the load for the building. We can go down, but we can just see the units themselves. So here, this is a typical unit. As I mentioned, it's 26 units such as this per floor. So this gives a total of 130 units for the G+4 typology. So on ground floor, we also tried to consider the people with disabilities. So here on ground floor, we eliminated one toilet to be used to be accessible to the people with disability. So that takes care of anyone who would be in this facility and would need to access such a unit. So the site, which I probably should have mentioned, is about 1 acre. So what this essentially means is that we can accommodate 130 units in 1 acre. So we're trying to maximize on the number of units we can actually do without compromising on the quality of space that we're providing. So yeah, for this typology, this is what we could achieve. Can go down to the next type. So this is the self-contained unit. Essentially, it's a studio apartment. So the difference is this: for these units, you would have your wait area within your space. So here we're looking at a typology without the need for sharing the wet areas. So here, the main design feature that we would see is that we're clamping up together the wet area so that, again, you can share the pipes. You can eliminate the cost of, elongated pipes for no reason. So here we're stacking all the wet areas again and just clamping up the areas that would be affected, so together. So here we were able to achieve 110 units in 1 acre. So the spaces are slightly bigger because we're accommodating their own washrooms and kitchenette facility, but just with a bed, and minimizing, any extra cost. So here we still have the courtyard, we still have the cross ventilation to the entire space, without compromising on, again, the standard of living. If you go down, we can see the unit in detail. So here, again, it's a grid. The grid is just 3.45. Again, load-bearing structure. Here we were able to achieve 110 units. So here the net area of the space is about, it's about 15 meters squared, sorry, 15.63. That's the net area. Again, those are just the features for this typical floor. So we can move on to the next, just of time. So in this typology, we decided to see how a mixed self-contained unit would look like in 1 acre. So here we decided to make it sort of a privacy gradient issue. So on the first 3 floors, we had the typical studio and 1-bedroom units. And then on the upper floors, we introduced 2-bedroom units as well as the 1-bedroom. So on ground floor, what we're able to see is, again, just the studio unit, again, with the white areas stacked together. But then now the interesting thing is what happens above on the next slide is, since we needed all the walls to align, our 3-bedroom units, they literally just intersect with what is below so that all the walls line up so that we can have the frame structure just working correctly. So it's just like bricks interlocking like a puzzle so that all the walls line up. And then we have the same grid running all through. So typically we can, on the next slide, we can just see the statistics for this block. We were able to achieve 81 units in total with 51 studio units, 6 one-bedroom units from ground floor to 3rd floor, and then on 4th and 5th floor, we were able to achieve 4 2-bedroom units, 6 2-bedroom units and 18 one-bedroom. So we had a total of 81 units for this specific typology. So again, it's the same design aspects apply for all of them. So yeah, that's what we were able to come up with for the 3 different units for this project. Yeah.
Thank you. Thank you, Architect Nicole, for shedding light on the architectural designs and looking at the numbers that you've taken us through. You've talked of 81 units in one of the typologies, and I know based on what everybody is asking would be how was this achieved? How was this weight distributed through the entire building, the entire structure? And I think it would be good for you to stay on to the very end so that any questions coming through, we can always react to this during the question and answer session. And picking on your last point with regard to the number of units and how the whole design was conceptualized, it would be good for us to listen to the structural engineer now, just to get a feel of the structural aspects of these building typologies and get to understand how this was put together. Of course, trying to strike that delicate balance between the structural integrity and the cost of delivering these typologies. So Engineer Brian, when you're ready, you could take us through the structural aspects of these typologies.
Yes, thank you so much for the opportunity, Patrick. Based on the architectural intent that was focused on this particular scheme, we, the structural engineers, decided to standardize the layout as much as possible in terms of material optimization, also while maintaining aesthetics and also the pattern of the layouts. Looking at the first slide, which now focuses on the main structural layout, specifically on the foundation and ground floor. Basically, it's a load-bearing masonry system. So with this, we have an advantage in terms of also optimizing the amount of material we use on the foundation. And in this case, we felt it was better to use a strip foundation for the load-bearing masonry. On the part footings, well, we focused on the staircase levels where it's basically a typical frame section. Again, when it comes to yeah, so basically on the staircase sections, that's where we focus on the concrete framing, just trying to minimize as much as possible on the output of concrete. And looking at also the sizing on the foundations, we considered the compacted earth material. And just before compaction, this foundation was designed on the aspect that the minimum foundation depth will be about 1.5 meters deep. So the moment we get there, that is where we expected at least a stable soil strata, which would accommodate all the building weight that is coming from these particular schemes. And based on that particular level, this is where now we start compacting the earth material. And if you just look at the breakdown, you can see at 900 millimeters deep, we've used thick marl backfill, which will be compacted. After the 900 millimeters deep, we now go back, we come to the hand packing rock material, which is 300 millimeters thick. And from there, we apply a bit of marram material so that we can keep the hand packing as level as possible to now come in and introduce the 50 millimeters thick concrete blinding. So the 50 millimeters concrete blinding, this is where now we lay the foundation for the ground floor slab. And from before laying that, of course, we cast the concrete, which is 50 millimeters thick. Afterwards, we now put a polythene sheet, which is basically a 1,000 gauge waterproofing sheet. So what this does, it prevents any sort of soaking in from the ground, underground water table that might exist or which will come in subsequent to stormwater drainage systems. So that already covers that bit. And then from there now, that is when now we lay the ground floor slab, which will be reinforced with BRC reinforcement. And now from there, that is where now we start putting up the load-bearing masonry system. On to the next slide. Yes, okay. Now on the part two, this is where now we focus on the typical structural floor layout. So regardless of the typologies the architect highlighted, we're basically looking at the maximum span in which each and every load-bearing support can achieve. So again, this is also a factor of material optimization, because you don't want to end up in a situation where we introduce intermediate load-bearing masonry walls, which might interfere with also the spacing of the architectural intent and also partly a bit of the aesthetic. So in this case, we stretch the load-bearing masonry to the limit until to the point where it cannot bear any building weight. But of course, you have to include a partial factor of safety to just make sure that the building is also optimum and at the same time achieves its structural integrity. And diving deeper onto the typical floor section, well, maybe you can't see it well, but I've just indicated there on the annotations that there are these ring beams which now sit directly on top of the load-bearing masonry. And based on the dimensions, they are 300 millimeters deep and 200 millimeters wide. And the reason why we picked up on those dimensions is because, again, going back to the architectural intent, we were looking at aspects of not also, blocking the openings such as the windows and the doors, and just trying to achieve as maximum daylight as possible, so that at least we can also save energy in terms of electricity, and also just maximize on the consumption of power. Just kind of just zoom out. Yeah, thank you. Yeah. Okay. So yes, so that is that. Explains on the concrete ring beams, and just to highlight further on it. Let's go look. Yeah, and just to highlight further on the concrete ring beams, basically this also work hand in hand with the load-bearing masonry, which also helps to alleviate part of the building weight that is coming, or rather, the building weight that is being channeled into the foundation. And then coming to the actual floor, we have 6-inch or 150 millimeters thick concrete flooring spanning across a maximum length of 5.3 meters. So basically what I mean by span is basically the distance between the supports. And in this case, the supports are the load-bearing masonry. So again, like I highlighted earlier, it's a matter of achieving or rather stretching the material as much as possible so that we can also achieve efficiency at the same time structural integrity. Moving on to the final slide. Now, I know I might have touched a bit on the key structural design assumptions, but I'll just elaborate further. So the load-bearing masonry, which is 8-inch or rather 200 millimeters thick, so it's serving as both the vertical structural support and also plays a role in the architectural intent, in which now it's also used part of the partitioning. So in this case, we're killing two birds with one stone. And that, of course, it's part of the material optimization. Number two, as you can see, there's barely any concrete columns that were used in the main building. And the fact that that was the case, we actually managed to utilize the natural material element, which in this case is the load-bearing masonry. And of course, in terms of the aspect of cost, that definitely helps also the developer and the investors to, build efficiently, at the same time also propagate on the scale of, the agenda, which is low-cost housing. Number three, the shallow concrete ring beams, like I stated earlier, these are acting as both the horizontal structural supports, which are also accommodating the floor system. And on top of that, they're also acting as lintels. So basically the function of the lintel is to make sure that whichever place of the building we have openings, the main structural part, or let's say the concrete floor, doesn't impose as much. Or rather, let me just take you back. The main reason why we introduced the lintels, you know, when you put up the window frames and the door jambs and the doorknobs and also the door frames, normally what happens is they tend to be compressed, basically due to the building weight. And when that happens, of course, it tends to damage the door frames, which in terms of functionality will be very much of a challenge. So, which again will bring in an aspect of maintenance. And you see, with maintenance, that comes with a cost. So to alleviate that, we utilize the concrete wing beams, which are also serving a purpose of, you know, acting as the lintels. And the lintel is just to accommodate that compressive strength, or rather just the crushing of the door frames and the window frames. Again, also, you know, maximizing on the amount of daylight. This also serves the purpose of the concrete wing beams. And going to the thin concrete flooring, which is 6-inch or rather 150 millimeters thick. This, if you look at in terms of the thickness, this is actually very thin. And the fact that it's thin, it's also increasing the headroom. So for the increase in the headroom, we can accommodate as much as building services as possible. And when it comes to the building services, I'm talking about now the lighting fixtures, talking about maybe if we maybe introduce mechanical taps, which in this case, we're not looking into that, but just the conventional building services system. So with that, it can always be accommodated with a lot of ease. And then last but not least, on the staircase, initially the design intent was to use concrete material, but because there's been a lot of focus on embodied carbon and one of the key highlights, which is concrete, that is a major contributor of greenhouse gases, we're looking at optimizing this material in the sense of, you know, just try to eliminate some of the components that were used in concrete and introduce mild hollow steel sections. So the mild hollow steel sections are basically light and strong steel material, which in terms of the strength is actually better than the concrete itself, and it's also flexible. So they can always work hand in hand, at the same time also achieving the material optimization, which has been the main focus on the structural design. Coming to the geotechnical assumption, as I mentioned earlier, the stable soil strata located at depth. Sorry, I mentioned 1.5, but the assumption was at 1.2 meters below ground. The reason why the assumption was made is because we, as much as maybe in the future we'll want to ground break and implement this sort of scheme, we don't want to end up in a situation where we go as deep as this particular depth that I've highlighted. And that, of course, will be a cost benefit to the whole team, of course, the stakeholders at hand. And in that regard, the soil strata expected is soft rock, which in this case it's marl. And then the strip footing, again, which is a very efficient foundation system, should be able to accommodate the load-bearing walls with very minimum dimensions and at the same time very much effective, even in terms of eliminating things like differential settlement. And differential settlement in layman terms is basically the displacement of where we find a particular section of the building is tending to lean more from the other side. So take, for example, the Tower of Pisa, which is in Italy. You can see the way it's sort of slanted. So that effect is known as differential settlement. And as introducing the strip footing, it will be able to accommodate that and balance everything out, including the building width that is coming from the structure, which I believe has been highlighted on the bullet point number 2. Again, also just to, last but not least, the shorter spans, which are the distance between the supports and the few stories. This also was a benefit to us, the structural engineers, because again, I will keep on emphasizing on this material optimization, and material optimization equals to cost. So the architect from our end actually gave us a very much of a helping hand, which in this case, I believe if we're to go further and implement this sort of scheme, it will definitely be of benefit for the greater good. Thank you so much.
Thank you, Engineer. Thank you for the clarity and the details you bring into the structural aspects of these builds. What you'll notice is that quite a number of questions are coming through on the chat. And again, the request we have is you stay on to the very end so that then we can respond to all these questions, of course, for the benefit of everybody who's attending this session. Before we move to the next speaker, I just want to repeat something I had said earlier on, that within this session, later on, we'll have a fireside chat just before the Q&A session, and we'll also get to hear from players in the affordable housing space on how we can improve the G+4 typology. So I'm urging you to stay on to the very end so that then we can get the full benefit of this session. And having heard from the architect and the engineer, I know the questions then that would linger in our minds would be, how much then would be required to bring these projects, or rather these typologies, to completion? And in view of this, I would want to invite the next speaker, who is the quantity surveyor, to share an outline on the cost components and provide estimates for completing the G+4 typology. So QS Jeff, you may proceed when you're ready.
Okay, thank you. My colleagues have introduced the design, and therefore for us is to place numbers against the design and also show you value. We walked through the design with the team and we are attaching cost to design. So this was a hand-in-hand process. So I'll move the team to what are the provisions we made, being that we have a site in mind. Then what are the assumptions that were made that got us to the cost that you're about to present to you. The first thing is that the site location is yet to be established. So as the engineer has provisioned, we allowed for depths of 2 meters where we find the actual strata that we'll be able to find our foundations. The structure is an interesting one because it's a box frame structure. Therefore, the structural costs are minimized. We have load-bearing walls, 200 mm thick, or rather we call them 9 inches, at the spans depending on the typologies, and not above 3 meters. So this will be a functional system, and therefore these helped in reducing the cost. The materials that were adopted for the finishes were locally available materials for the doors and also for the windows. We used steel windows, and then for the doors we had the semi-solid doors that are available in our local market. For the floors, we allowed for hardened screed that is steel trowel, and then for the weight areas there was wood floated, but finished with tiles in some sections. That's the locally available tiles. If you move down to areas where we have the social housing that are for the low-income earners, then you realize these would be feasible. The other one on the ceilings, we did quite an interesting thing. The architect looked at provisioning for a fair first finish to the ceilings that again saved on our cost of plaster. On the discharge of fall water and stormwater systems, we assume that we're going to use a county council system, being that if you visit the areas that you're looking at, like the Rai, Ruma, those are the Eastlands areas of Kenya, then you'll realize that these areas, the method of disposal of waste is through the county council system. And finally, in our cost, we took a bit of a different approach, and this is the gist I want you to be with me. We broke down the cost into materials, labor, and equipment. So our costs are actual costs that were incurred that will be incurred during the execution of the project. These we work hand in hand with our partner, that is CAF, and through their assistance, we're able to have the numbers of actual cost and also from our existing projects on what has been incurred. So the footnote on this is that we've not considered the contractor's profit on this, but we're looking at the development of cost from first principle so that we can know what are the actual costs that one spends if we are to exclude the contractor's profit. But should we include it, then this can be added as a standard practice in the market. We have it between 15 to 20%. Thank you. So I'll move you through we have 3 typologies as has been introduced by my colleague Nicole. That is the first typology, which we have the 1-room units, which are 130 number, the second typology, and the third typology. So I want you to walk with me on this. On the first typology, we have an interesting cost presented ahead of us. We are achieving 62.7 million. That's the construction cost, actual cost of the project, bit of assumptions that have been introduced to you. And our cost per square meter was 25,043. Yes, that was the cost that we had per square meter for the one-room units. You realize our washrooms are clogged on one end, and therefore these also help reduce the cost, apart from the other cost assumptions that have been introduced to you. So if you look at the cost breakdown that is projected, then we, after breaking down the cost into material, labor, and equipment as highlighted, we went to give costs towards each and every room or facility. So the breakdown is we have the one-room units, we have a cost for the one-room units, we have a cost for the shared washrooms. The ground floor is a bit different from the other floors because also the ground floor took care of the persons with disabilities. We have the first floor to now the 4 floors which are typical. Then you also have the circulation space, that is the corridors, the staircases that were part of the floor area. And with breakdown of this cost, then it helped us in really understanding the numbers that will be allocated to each unit, where our next presenter will take us through now how this cost could aid to guide on the rental income and all that against our units. On the external works, we have a bit of paved areas, but we assumed normal compacted sections without a finish, that those are workable for the courtyard. For stormwater and fall water I've introduced, and then you also allowed for a boundary wall because, as Nicole introduced, instead of the club back-to-back buildings for indoor air quality and environmental sustainability, we have a building that allows for free flow of air, and then there's a boundary wall towards the edges. That was at 1.9 million. So the external works was a bit minimized to 2.7 million, and then we allowed for preliminary cost that involves water, electricity, bit of approval fees. So that is those are some of the preliminary costs, and then the contingencies in case anything comes up. So that's what summed up to 62.7. The approach on the other typologies is the same, and therefore we'll just take you through the numbers. We also, like the moderator has mentioned, will allow for questions and answers. So we'll move to typology 2. In typology 2, you realize we have the difference between typology 1 and 2 is 2,000 shillings per square meter. On typology 2, we had 27,000. That is the cost per square meter. And on this typology, you realize we have studios which are en suite. So the number of wet areas are increased, and this is what led to slight adjustment of the cost. The studio units tend to be slightly higher as compared to the one-room units, and because of the factor that I've mentioned, we have 110 units, and the cost is as broken down. It's coming 70.3. It's higher than the other one, and even the cost per square meter again, it's at 27,150. Thank you. We'll move to the last typology. Typology 3 was a bit interesting because we had the studios, the 1 beds and the 2 beds in different floors, and they were allocated differently. We again broke down these, and our construction cost on the buildings was at 67.8, and then the external works were standard across the typologies, and then preliminaries and contingency we had below. So for these, it was 26, slightly above the one-room units and also slightly below the studio units, because if you look at the studio units, then we have more partitions, we have more wet areas, we have more washrooms, more showers. That's why the cost is a bit different as compared to the one-room and two-room units mixed typology. And these we achieved 26,300. And I believe that marks the end of our 3 typologies cost. I'll allow room for any questions on these at the end of this presentation. Thank you so much.
Thank you, QS Jeff. I think you paint a clear picture on the cost components, but again, looking at what we have on the chart, quite a number of questions are still coming through, and it will be good for us to stay on as well, so that then we can respond to the queries coming through for everybody to be on the same page based on the numbers that we have shared. A very warm welcome if you're just joining us, and exploring new builds for very low income earners is a topic of discussion today, where we are rethinking affordable densification for informal settlements. Again, at your convenience, feel free to leave a comment or question in the chat, and we'll be happy to react to this towards the end of the session during the question and answer session. Now, having heard from the three professionals, that is the architect, the structural engineer, and the quantity surveyor, I think it would only be fair for us to also get a feel of how this work was put together. And to guide us through this work, I'll invite Michelle and Alan to explain how this feasibility was conceptualized and how these numbers and how this work got to what it is now. Michelle, Alan, when you're ready.
Thanks, Patrick. So for us to be able to do the G+4 financial feasibility, we started off by looking at land values across different parts of Nairobi. And that's the north, south, east, and west. And specifically on Donholm, Githurai, Wiru/Kino, and Naivasha Road. So we compared the average land cost per quarter acre and with the rental prices and with the utility costs for different types of units. That's from the bed sits with shared facilities to self-contained bed sits and to 1 and 2 bedroom apartments, just to see how they vary along major transport corridors. And a few interesting trends actually stood out. At Donholm and Wiru/Kino have the highest land prices at around 25 million and 30 million per quarter acre respectively, while Githurai at 12.5 million shillings was the most affordable. Despite this, the rental values for 1 and 2 bedroom units are quite similar across these locations. For example, a 2 bedroom house in Githurai, rent is around 22,200, while when you compare it with rent in Wiru/Kino, it's around 22,500, even though Uviru's land is more than twice the price of Githurai's land. This just goes ahead to show that land cost alone doesn't dictate rent. We also noticed that rent jumps from around 2,000 to 4,000 from shared to self-contained bed sits, and this extra amount covers private bathrooms, a small kitchenette, a small living area, and the psychological comfort that comes with just having your own space. And this also just shows the sign that people are sometimes willing to pay more for privacy, and even in dense and low-income neighborhoods. Because by just adding one facility like a toilet, rent is being pushed up. And this is not just because of the added convenience, it's also because landlords know they can charge more in a market where demand seems to be greater than supply. So in many ways, affordability isn't just about land costs, it's also about how much housing is available. And then lastly, on the last column, we have the utility costs, which also rise with the unit size. One, because of higher consumption, and two, due to additional infrastructure. Like now you have individual water connections, individual electricity meters, and so on and so forth. And so for developers, this might mean they need to constantly balance quality with what tenants can actually afford. And I'll hand over to Alan, who will dive into the business case behind each of these technologies.
Yeah, thanks a lot, Michelle. And thanks everybody who has gone ahead. I think the most important thing to take away from this presentation is the fact that we've been asking ourselves, basic question: how do we provide decent housing for low-income earners? So the first part of the presentation was a technical feasibility section, where you saw the architect, engineer, and QS take us through the technical aspects of what it would take to bring a G+4 project like this to light. I know it's interesting that most of these sessions, when we talk about housing, we rarely get into the nitty-gritties of the technical aspects. So that has been very useful. So this section now is where we're talking about the financial feasibility of what it would mean to go beyond the construction cost and put together the project in a manner that can be able to be executed. Of course, I would expect interesting questions to come up around the costings per square meter, but we'll be happy to address them at the Q&A section. So really the question is, how do we provide decent quality housing for low-income earners in a densified manner? So as we were considering the financial feasibility, we did make a couple of assumptions. As architect Nicole mentioned, on the land size, it is a quarter of an acre that we use to design these particular parcels of land. And of course, the number of units are varied from bed seats that have shared facilities to bed seats that have self-contained and then mixed-use typologies. The importance of us to consider the different block typologies is because these are the observed typologies that you can see in the market. For instance, if you go to low-income areas like Pipeline, you will be able to see these kind of buildings that have come up that have bed seats with shared facilities. And you can also see the progression from shared facilities to self-contained. And of course, the question we're asking ourselves is how can we be able to do this in a dignified manner? So that is what primarily informed the different block typologies that we considered within this particular project. I won't go into the details. We've already covered the ground plus 4 and the number of bathrooms per floor. I think what I would want to highlight is, how we put together the other costs, because Jeff has really taken us through the hard construction costs. So from a financial feasibility perspective, we also asked ourselves the professional fees, marketing, development, overheads, and compliance approvals, how would those costs be able to stack up? And we use the reference point from the housing development cost benchmark for Kenya that CAF did in 2023 to be able to derive those particular assumptions, and we held them constant across all projects. Now, the one thing that we did not apply from an assumption perspective is the cost of finance and the developer margin. So there are two critical cost elements that we omitted. So that's the first one. The second one was already mentioned by the QS in terms of the contractor margin. And I think it's also a question for us to consider in the space regarding the value chain of delivery, because you might find there's a contractor margin that's really placed, and then a developer margin, and then of course a cost of finance. So we're looking at a bare bone sort of approach to be able to quantify the actual cost it takes to deliver such a project. Now, when we put together all these costs, this is the resultant sort of business case from a cost perspective. As you can see, we held the cost of construction constant across all nodes. So across Uthiru, Kinoo, Embakasi, Donholm, Naivasha Road, and Githurai, we held the cost of construction constant. Of course, the pushback from this might be that the transportation cost of materials across different locations will be different, and we do take that. But what we wanted to evaluate more critically was the input of land, whether it would be able to affect costs and the resultant revenue in a significant way. Because it is easy for us to come up with these particular projects, but the place to implement them is what was a critical issue for us to be able to solve for. And of course, we're hoping that we can get development partners that can be able to roll out these projects in. So for this particular case study, for the shared facilities, you can see that due to the price of land in Uthiru, Embakasi, Donholm, and Naivasha Road, the cost of delivering the entire project sort of rises. So we're talking about 98 million shillings at Uthiru and Kinoo, then 93, at Embakasi and Donholm, and then 89. And that is also replicated in the cost per unit. So the cost of a single unit was about 757,000 at Uthiru, and it falls all the way to 662,000 at Githurai. We also did a development cost per square meter analysis across all locations, and then did a differential sort of a comparison to see what the difference is across different locations, given that the cost of construction was held constant. So it was an interesting analysis for us to compare how much more it would cost to construct in different locations, given the plug of land. I think it's so important for me at this point, I think it's also been posted, that every technical design presented, both architectural, structural, and the QS estimates, are available on our website. And so is this Excel feasibility analysis. So in case you want to sort of play around with this analysis more, you can be able to find it on the CAF website, and it will also be shared on the FSD website. So if we move into the second typology, and for context, in this analysis, I primarily focused on comparing the shared facilities and the self-contained. For the self-contained, as it was referenced by Michelle, there is a premium in terms of what the rental would look like, but also from a delivery perspective, QS Jeff mentioned that the delivery of self-contained units would be slightly more. So we're looking at a delivery cost of about 70 million shillings. And that can be reflected across all locations. So if you look in the previous slide where we had 98 million within Uthiru, it comes to about 106 million for the self-contained facility. And similarly across all locations, there was an increase in the delivery aspects. And that was also replicated across the delivery cost per unit. So that becomes about 969,000 per unit in Uthiru, and it falls all the way to 810,000 at Githurai. So I guess the question for us would be, given the differential land prices, how does that reflect from a return perspective on a rental side? And it's important for me to make the caveat that when you're talking about low-income housing, and I think that will come up in the fireside chat, what's important for us to consider is a dignified rental approach. The discourse on affordable housing sometimes tends to focus a lot on home ownership, while the most critical aspect is actually access to this affordable housing. So even when it came to analyzing the sort of returns that you can get from this particular investment, we also took the approach of dignified rental, so modeling the investment from a rental perspective. But once you get access to the Excel file, you'll also see that we considered a sale perspective and what the resultant returns would be. But for the purposes of this presentation, as presented, you can see that there is a premium to having self-contained facilities. So about 4,000 shillings in Uthiru, if you compare the table below, and this is the same across all locations. What was interesting, though, is that the rental premium in Githurai that we found from the desktop research was not that high in comparison to the other locations. And so what does it mean from a rental perspective? So if we look at the gross yield, and for purposes of this particular analysis, the gross yield just meant the annual rent divided by the project cost that had been shown in the previous slide. We can see that for the shared facilities, the gross yields dance between 8% to 10%, while for the self-contained beds, it's because you're able to price a higher rent, then you're able to get between sort of 10% or 12%. We then assumed a 10% operating cost expense, and that's the difference between the gross yield and the net yield column, to be able to cater for those expenses, and that's where you can see the drop. But suffice it to say that on average, the shared facilities dance between sort of 7.8 or 7.1 all the way 9.7% from a net yield perspective. For the self-contained bed seats, of course, they are a bit higher. So we're talking about 9% to 10%, which is commensurate to the ability to collect higher returns from self-contained units. So it gets interesting, the payback period. So simple computation, of course, are showing us that it takes much longer to get payback for the shared facilities in comparison to the self-contained bed seats. And this is, of course, on account of the rental premium one is able to charge. So you're talking about an average of maybe 12 years for the shared facilities, compared to about 9 to 11 years for the self-contained vaccines. So that in a sort of broad sense is the approach we took for the feasibility study. Behind this sort of summary is a much more detailed feasibility Excel workbook that will be available for participants to sort of play around with. I did mention that I didn't sort of put the mixed typology block on this particular presentation, but you'll find it in the Excel sheet because it had much more extensive analysis. But I think I'll pause there for now and allow us to proceed to the next session.
Thank you, Alan. Thank you, Alan and Michelle, for sharing insights on how this was put together. But again, as we've seen with the previous presenters, a lot of questions are also coming through, and it will be good for us to look at them and also address this during the Q&A session. Thank you everybody for joining. And you remember earlier on I had mentioned that at some point we will also have a fireside chat session. In this very session, we'll have a livelihood impact fund, which is LIF. We'll have Real and UN Habitat also share insights on the key considerations that they feel could be brought into implementation of these typologies. And to kick things off, I would like to ask Beryl Kanyile, Etta Madete, and Daniel Udama to please turn on their cameras and unmute their microphones as an indication that they are ready to begin. And as they prepare, I would want to give a brief of who these three participants are. And I'll start with Beryl Kanyile. Beryl leads the UN Habitat Kenya Country Program, coordinating urban development efforts with partners. She also serves as the Chief Technical Advisor and Project Manager for the PINUA project, which is a collaboration between the European Union, UN Habitat, and the government of Kenya. Of course, we look forward to hearing from you, Beryl. Etta Madete, who is the second panelist for this session, is an architect, a sustainable design expert, and a housing developer who is passionate about sustainable real estate. She's a former University of Nairobi lecturer, an EDGE expert, and an Aspen and Mandela Washington Fellow. The third participant for this session is Daniel Mudhama. Daniel is a housing and construction project manager at Livelihood Impact Fund. With his current assignments, including a residential development in Kibera, where they use interlocking block technology to provide safer, improved housing for the low-income earners in the informal settlements. So welcome, Beryl, welcome, Etta and Alan, and I hope this will also make for a very interesting conversation, even as we dig deeper to get your take on the G+4 typologies. And the first question, in the interest of time, which I want to pose to the three participants, starting with Etta from Real. Could you kindly introduce yourself and also give a brief description of the organization that you represent? Etta?
Hi, everyone. I hope you can hear me. My name is Etta, as Patrick shared. I'm an architect, housing developer, sustainable design expert, but somebody whose sole passion is trying to figure out how do we bring the three worlds of technical information, real estate development, urban economics, land policy, and the sort of pressing issue of affordability together to actually have typologies that can actually scale in emerging markets. I represent two organizations, Real and Zima. At Real, I'm the portfolio manager, and Real is an impact fund that over the last 30 years has invested in the development of affordable housing across over 20 countries in emerging markets in Africa and Asia. The beauty is that right now, after 30 years and hundreds of projects, we're trying to consolidate that information to see what are the typifications, what are the typologies that can work in different contexts, urban, rural, different land prices, different transaction formats that can really help all of these initial projects that were built scale. At Zima, I'm an affordable housing developer who we have built a ground+4, ground+6, ground+7, and we're exploring how does then that scale to bring the cost down with a standardized design. And so this work is very dear to my heart because I've always felt that we need more technical information. And the second reason from both Real and Zima is that I believe affordable housing is its own asset class. And so the simplest way to make sure that we can scale really good quality, dignified, dense urban developments is by making sure the technical information and technical professionals are not the barrier, but the enabler. I'll stop there for now, but I'm looking forward to the discussion.
Thank you, Etta. Maybe before we let you off the hook, could you briefly define the vision for the organization the two organizations that you represent?
Yes, so for Real, the goal is to do affordable and sustainable housing at scale in emerging markets, both through three aspects. One is through affordable housing finance, so enabling financing systems in emerging markets to work. That's both from credit assessments, from figuring out innovative ways of reducing the interest costs and the cost of development finance, and on offtake financing. The second aspect that REAL is working on is on improving efficiency of delivery of housing. So ensuring that there's capacity building with partners on the ground that can then scale and institutionalize. We have a lot of small scale landlords. How do we get that sort of energy of supply of housing to be more institutional, to attract more institutional scalable developments? The third is data. We work with open access, we work with CAF, we work with many different organizations to make data available and open sourced for both green, but also gender inclusivity. So those three aspects: finance, delivery on the supply side, and then the third is data. At Zima, it's about scale. We've done our first pilot, and the goal is to work out how do we scale in what I consider dignified density, both at the apartment and the courtyard style housing, and make that financial case for commercially driven projects that are still dignified. So those are the two missions and visions.
Great, thank you. Thank you, Etta. We'll move to the second panelist, Burial. Probably just to introduce yourself and also describe the organization that you represent. Burial?
Thank you very much, moderator. Afternoon to everybody, and thank you for the information shared. I think as I've been introduced, my name is Beryl Kanyile. I'm with the UN Habitat, which is a UN agency focal point for sustainable urbanization, development, and matters related to urban transformation within the UN system. So I'm responsible currently and heading the Kenya country office and also managing PINO projects and overseeing some of the programs within the Kenya country office, working with partners such as government, donors, civil society, and counties and national government. So I've worked before I'm an engineer profession, a civil engineer. I was very intrigued looking at the structural component and how that pans into financing. I've worked previously in the urban mobility, human settlement and housing, focusing on different housing responses, looking at various economy stream. And I've worked within the engineering infrastructure relating to that, basically the spatial transformation and some of the input tools that actually enable spatial integration and spatial transformation, and looking at the financial component, and also been exposed in my previous life within the National Treasury, designing the financial reforms that really respond to achieving the economics of low-income sectors. So the vision of the organization that I work for, as I've stated, that we are mandated by the UN General Assembly to really promote social integration, sustainability, and to ensure that cities and towns are resilient to all the impact that we see as a result of urbanization. And we've pegged our vision based on the reviewed strategy that is going to be approved next month, actually, through the UN Habitat Assembly, which really brings home the nexus of housing, land, and basic services. So the understanding is that if we centralize such a nexus, we're able to spin off some of the climate resilience, energy efficiencies, and all other key elements that really are significant in transforming some of the issues that particularly cities in Africa are grappling with and across the globe. So we implement this through ensuring our territorial planning, our land, urban and financing models, through normative and technical work in which we work across countries that are represented within the globe. And we make sure that the participatory tools, ensuring that multi-level governance is involved, knowledge and data, digitalization, and we ensure that the capacity and knowledge, there's a lot of best practice that we issue and we work with government in formulating it, and ensuring that resource mobilization to make sure that there is impact and there's sustainability moving forward. So in a nutshell, that is the vision, and we've encapsulated it through the strategy from 2026 to 2029 moving forward. Thank you.
Thank you, Beryl, for that intro. We'll move to Daniel. Daniel, if you could please introduce yourself and also describe the organization that you represent.
Thank you so much, our moderator. So my name is Daniel Mudama, project manager, Livelihood Impact Fund. and to be specific, housing and construction. We're doing some construction work in Kibera, the slums currently. Although we are targeting to expand to other parts of Nairobi, but for now we are specific in Kibera. So Livelihood Impact Fund is a US entity that is registered under US. So what we do, or what LEAF does, is that it supports organizations as well as creating employment and also improving livelihoods of citizens, and especially from the underserved communities like slums, including Kibera, Mathare and Huruma, and Mukuru and others. So what we are doing, we have several projects as LEAF. Apart from construction, we have others which are going on in Kibera. But my main focus is where I'm leading, that is construction. So we are doing some construction work in Kibera. So far, we've done 8 units are complete. We did last year from August to around November, or to around September, that is, sorry. And this year we began other 21 units. So we are aiming to complete by June and mid-June. And then we have other projects which are coming concerning construction. So our long-term vision for the organization, especially for the construction work which we are doing, we are aiming that by the end of this year we shall be doing or we shall have completed around 500 units in Kibera. And apart from Kibera, we also aiming that probably by the end of this year we shall have other units which are constructed outside Kibera. And the main focus, we are looking at people who are low earners, whether in Kibera or any other place. Thank you for the discussion which I've seen. I've seen the cost which we are targeting, because we are looking at whether when we are doing the construction, can we do it under 30,000 shillings per square meter. So I've seen there's light that, and that exclude the cost of land and cost of all the other particulars which are needed in registration, like all those like NC and all other things. When we are doing these constructions, looking at the rent which we are thinking of, whether in Kibera or outside Kibera, because target people who are the low incomes, we are looking at can we achieve a goal whereby we can construct houses and the rent will be something like 5,000 to 7,000. So I've seen a lot of discussion here, and it seems that there's light. Yes, thank you so much.
Thank you, Daniel, for that intro. And I think you've quoted quite a number of areas, specifically Kibera, Huruma, and the likes, where this type of typologies would actually fit. I don't know, from a project manager's standpoint, how would these G+4 typologies fit in the type of work that your organization undertakes? Daniel, if you may.
Yeah, thank you so much, Patrick. So when you look at some areas like Kibera, the land is owned by the government, so they don't have the title deeds. So in Kibera, we are using twist blocks technology because we are so skeptical such that in such a case, the worst scenario happens, and then the government decides to take away or to clear Kibera as the narrative has been going. So we can possibly take away our blocks and maybe move them to another area. So it's a technology which we've already tested. Around last year from Feb, we constructed a house in Dagoretti, and we completed around April. And this year, Feb, we took it down. So we've tested that our blocks we can construct and deconstruct. So in Kibera, we've not done G+4 so far. So the higher we've done is G+2, although we are targeting to do the next project G+3. But based on your question, the G+4 may not perfectly fit in Kibera or in slums or those areas. But it fits so well in other areas of which we are also targeting, like Kawangware, because Kawangware is one of the areas where we have an interest. Pipeline also, it can also fit because there's an interest in pipeline. So G+4 can fit so well in those areas, but I'm not sure whether it will fit well in areas like Kibera.
Thank you, Dan. You'll hold that thought because we'll come back to you with a further question. But thanks for highlighting the issues you brought out. If we can quickly also hear from Etta of Real, because based on your introduction, your role in this society is you're an architect, you're a developer. Having heard from the various professionals we listened to this afternoon, what is your perspective on the shared facilities for the low-income housing units, Etta?
Just from the top level, I think, first of all, the information is very useful to Real to be able to create templates that can then standardize some of the typologies that we've built over the last 30 years. The second thing that's important is that it has focused on an urban typology, which is often overlooked, urban and dense. So that I think that's very important. And the third question, which you've mentioned, which is how are the amenities supporting the kind of social housing you're trying to provide? I think the amenity question is extremely important when you're doing social housing because you're almost trying to compare how you're combining the sort of self-contained units, the bed-sitter tenement style units, and then the sort of shared facilities. Secondly, the reason I think it's important is because of the cost of the amenities and the impact it has on major things like piping, etc., but also property management. How do you sort of get your net utilities? How do you consolidate those utilities? So I think that it's very location specific, but also market driven. There will always be a gap between the jump in informal settlements to the jump to informally built formal housing, that's the tenements, to formally built formal housing, which is sort of what we're trying to deliberate here. And the biggest jump between those is, as Alan and Michelle highlighted, it's between 2,000 shillings to 3,000 or 4,000 shillings to 6,000 shillings to 17,000. So that range between paying rent of 1,000 shillings to paying rent of 5,000 is literally the bridge between either the right location or the amenities being provided. And so getting this analysis is useful to sort of see where is the actual gap in the need. And I'll keep saying it over and over again, the private sector will provide amenitized as long as the land price, etc., is done. It is a sort of range between 2,000 shillings, 1,000 shillings to around 3,000 that private sector, even Real, because Real funds developers with commercially viable projects, the numbers just don't work. On the other technical side, it's the county may also not allow you to do those kind of housing legally using the legal steps. So that interrogation of that difference, the difference in providing amenities helps to sort of categorize where the gaps are and where we need to make sure that the numbers that the market are enjoying in informally built formal developments can maybe even be enhanced both in formally built formal developments like social housing, like what you're talking about, and be able to bring the numbers down at scale so that we can crowd out informal settlements and informally built formal housing that doesn't follow the rules. That was a long way. So that was sort of like a long technical way to say it's really important that even as we're doing this study, we quantify, we sort of blur out the stuff that is just the same and quantify those amenities and see if it's a deal breaker on the rental side and a deal breaker on the developer side or a deal breaker on the building code side.
Okay, thank you, Etta. I'm just wondering, based on your other cap that you wear as a profession, as an architect, in your opinion, what do you think could be done differently in view of what you've had, the numbers you've seen? What could be done differently?
I'm saying this directly from experience. Our Ground+4, one of the blocks that we've done in Zima, we did it load bearing to save money on the structural, but that particular decision is really dependent on context, not just on the soil or the soil strata in a certain area, but how developed a certain area is. And so I'd put it in the comments, load bearing versus frame not only affects concrete, et cetera, but also if you're a developer and you do ground+4 thinking you're going to do load bearing, yes, you'll save money. But if because of the geotechnical that's done a little bit further down, you have to switch to frame, you can switch to frame, but in that case, you should go a little bit higher to make efficiencies on your frame because a frame is a frame. So I think the one thing I would want interrogated properly is what if you're in an area where you can't do you can do ground+4, but you can't do ground+4 load bearing. And that is basically a technical assessment because the numbers change a little bit. And I know Engineer Brian, and it's one of those things that can throw your numbers off. And I just wanted to check if that's something that could really be interrogated a little bit further. The second thing is I understand the sort of benchmarking on land price. I put it on the comments and Sita commented, it is the 1 acre versus parcelization versus 16th versus 8th. It's very romantic to do dignified density when you have an acre, even when you have a quarter acre. How do we get that to an 8th or a 16th, which is what I call urban acupuncture? We need to go into these neighborhoods, put something that sort of exemplifies this, and then inspire a sort of difference in a certain neighborhood. So those are the two things I would say. There's nothing wrong. What the work that's been done is fantastic. It's just those two things that are almost like flags, because the size of the land affects the price of the land, which then sort of like, I'm wondering if it then changes the sort of rates, if the land is smaller, and also it affects dignity. So how do you get natural light and the wonderful work that Nicole did on a smaller plot? Like, what are the rules that you change? And again, if you're on a 16th, should you really do ground+4? I don't know. Especially if all your neighbors do ground+30, then you are compromising the quality of life. So it's like maybe you need to face the roadside and some of those other rules that depend on the ratio of land sizes. So land size is not just a factor of price, it's also a factor of how the massing changes the rules for social housing. But again, social housing is better done at scale, so that's another whole debate.
Thank you, Etta. Thank you for these insights. We'll still come back to you with a follow-up question just to clarify further. But before we get there, just a reminder to all the participants that you can still continue channeling your questions and your comments, and we'll endeavor to react to this during the question and answer session. Allow me to proceed to Beryl. And for Beryl, based on your experience in the built environment and the underlying demand for housing in Kenya, is there potential to test out such pilots based on how you see the whole conversation unfolding? Beryl?
Well, thank you very much, Patrick. Certainly, I do think based on the work that I'm doing and based on my experience, particularly plugged in with the State Department of Housing and Lands and Urban Planning, there is scope to test such pilots. And particularly because it's an opportune time. We all know that the government of Kenya is prioritizing affordable housing. And that presents a scope to basically deal with how we articulate policies on the basis of piloting what is really affordable. And I think the typology the three different typologies that have been explored today, we associate with them because when we understand what came out of the I think it was last year, towards the end of 2024, it was the Housing Basic Survey that was published, which really confirmed that 70%, there is a market gap of 70% in terms of rental, but where that market is found in informal rental, particularly in informal segments. And why they are pulled today, it's because of the cost and the affordability as deemed. But obviously, we're not dealing with issues of structural integrity. We're not dealing with issues of location choices. So from where I've expanded myself, so we are currently piloting, I think it's a G+5 that we have designed, which is really similar dynamics than what is came out, I think, on your second typology, where we can pilot, co-pilot This is a program that we are currently undertaking with the EU and the government of Kenya. And I think the opportunity is that the steering committee include the government of Kenya, the Affordable Housing Board, and as well as the EU and other development partners that are on board. And there's room for other development partners so that we can maximize on the technical output and the work that we are currently posturing, and we can make sure that we apply and we share what has came out of that. So there is an opportunity in Kisumu. Our pilots are in 2 different counties, in Nairobi and Kisumu, but based on how I've understood the outcome of these typologies, Kisumu, particularly an area called Kibuye Estate, where we have believed as the UN Habitat that the first thing that we have to do is to validate what we want to do or what we wish to do with communities so that it actually co-owned and co-developed and co-created. So we're working with the Kisumu County and the communities that are affected. It's an estate that already county is managing rental stock. So there is a culture and a nature. So our main focal point is really to establish this social rentals. I think the speaker, when they were talking about a general assumption at the end, and even I think ETA did articulate that there is an under-subscription or under-focus on rental housing. And we like to believe that based on how the market gap is directing us, we really need to respond to that gap, but respond in a way that is sustainable and that will be affordable. So I think there's an opportunity to explore and pilot, because that is exactly what we want to do, so that we can inform our normative work and what really is required from a financing point of view. This happened hand in glove with financial modeling, so that we can understand what is the role of financial institution, where do they need to pitch themselves, and how do we influence policy, so that we make sure that these things are articulated. Our main objective is that what we do find translation in how governments structure their policy and how do we reform particular policies for sustainability. So I see an opportunity in Kibuye, which is in Kisumu. This is under the social corporate rental stream, amongst the 3 streams, but also there is another incremental green housing stream, where the architecture was presenting, and I saw an opportunity where we've done an analysis of what materials are available in Kisumu, particularly in Muhoroni, because the input cost, we've understood doing our typologies and testing, that there is an input cost that is quite key. So accessibility and availability of material, and which impacts lighter in the cost from a geotechnical perspective, is very much important. But the key objective amongst others is we want to understand what will be the operational model. Because if it's a low income rental, it's very important. How do we achieve sustainability and efficiencies? So how do we model how we can actually assist communities to own, but to manage collectively, and to make sure those units are sustainable for generations to come? So our key objective is to establish a financial model, but also a model of management in such a level of income scale. So certainly there's an opportunity for that, and we can expand our incorporation to make sure that the development partners forum that we have, we include this model, and then we can test it and pilot it alongside what we're doing. Thank you.
Thanks. Thank you, Beryl. And maybe just a follow-up question. The fact that you say there's indeed that opportunity, what could be the process of testing out these pilots with reference to the type of work that you're undertaking?
So the process as we've unfolded, because what we've established is the project governance structure, which ensures that the county government, because the land belongs to the county, and we've had to receive consent from the county to actually utilize that land to enhance what they are doing. And we're not only doing that, but we're doing the land use planning, assisting them to actually achieve their land spatial planning, and as well as the housing policy. So that is the opportunity to ensure that the actors in that particular space are onboarded. And indeed, we have those kind of consent from the county to make sure that these kind of typologies that we've just seen, we also validate through the same mechanism. So there's a community mobilization strategy and plan that we are currently executing. We ensure that communities find themselves inputting to how they see what is happening and how they see it translating and how they understand the accessibility of such. So I think it's to plug into those tools that we've deployed in those programs and to make sure that these kind of typology or whatever typology that we agree with, that we move forward, we make sure that we put in there. So that is an opportunity and it's a critical step that we do have to put it into. And then we make sure that we really understand what I saw from in me receiving such an information was that I was wondering what is the land readiness, because we need to understand what is the status of readiness in terms of that particular land, because either then the internal infrastructure, but there is impact on the bulk infrastructure. So we do need to understand the broad feasibility and what is critical for us to really attain those efficiencies and the caps in terms of the cost per square meter that we've spoken to. So those kind of things, and you can partner with the county because they are able to tweak their infrastructure plans to focus on what we are doing. So that's the opportunity. I think the relationship that we've created, the agreement and the collaboration we have with those crucial actors, I see that as a vehicle in which we can enter this, but acknowledging that communities need to be validated, they need to accept, and they need to be socialized in what is happening, and so that we can co-create and cooperate with them. So, and also there is financial sectors that we've touched base with, and I think it's important that it also can be tested if there's any other mechanism, because we could need to manage and operate it in the future. How can they assist in that regard if there is a need for co-funding? Thank you.
Thank you, Beryl. An interesting concept you've brought out on land readiness, and I think this then redirects me back to you, Etta. And in view of what Beryl has said, I don't know what areas of collaboration do you foresee in development of these typologies in the near future?
I would say that it is combining the 2 points of expansion that I mentioned. One is in really doubling down on the actual cost delta that this typology has. I put it in the comments, this typology has with what is already being done. So what if a developer takes 1 acre, fills it up, and just saying, like, what is the actual delta, so that you can actually make a case on why this is better. And the delta would basically be either compensated by lower land price or higher rental unit values increase, because you're using lower density, you're not doing the norm. So I think the way that we can collaborate, especially with the private sector, impact fund, developers, both hats, all hats, is just really pushing the understanding of what is the compromises being made and how do we make that delta market driven, not impact or I have a big heart driven. That if that delta between what Zima, I've seen Unity Homes on the chat, what developers are actually, I've seen Michael on the chat, that's Natureville. If we can sort of say the delta between social housing, this 27,000, the work that LIF is doing, the work that UN Habitat is doing, and like affordable housing developers is X, and this X comprises of land, understanding with the government, maybe better subsidies. If we can get that, then we can really drive both private and public sector to see where we can collaborate. And so that's where I feel the collaboration point is. Private sector, NGO, public sector, it's in that delta. That's where the money and the energy needs to be spent so that then the scale happens and is driven by market forces. It's not subsidized by market corrections that are not happening in our generation. So I'll just leave it at that, which is, can we collaborate on getting the math on the delta correct so that the market can feel like they can participate in the supply of housing?
Thank you, Etta. Same question, probably posing to Daniel from LEAF. What do you think would be the areas of collaboration with this level, with this type of typologies? Daniel?
Yeah, I think all of us, we are in agreement that whatever we are providing, we need to provide something which is better than what is existing, not forgetting our market or our targets. When it comes to the land, especially the pricing of the land, in Nairobi, the far you go from the CBD, the cheaper the land becomes. The closer you are, the more expensive the land it is. And then we'll find out that our targets are not very far from the CBD. Like say that we are targeting guys living in Mathare. We cannot have a land in maybe Juja because it is going to compromise most of their daily activities. So when we are targeting some guys who are living in Kibera, for example, we need also to look at the land which is surrounding the area, like Kawangware, for example, which is not far from there. So the cost of the land is it has a very big impact on whatever work we are doing. So I think the area of collaboration here is how can we ensure that we keep the cost of construction as low as we can. I know there's an area where we cannot get, but we can try to keep it as low as we can. And this comes as if we do all the NCA requirements, if we do all things which are needed in construction, then now we are trying to make the cost as low as we can, because the target, as I said, the rent should be around 7,000, maybe for a single room, with shared amenities, of course, like toilets and all those things. The spacing again should be reduced. So I think from my area and from what I think is that if we can get the right people who can help us achieve the law that is the cost of construction. Like for example, today we are talking about in Kibera we are talking about something like 20,000 per square meter or 18,000 per square meter. But Kibera is a different dynamic. So if we can get someone who can provide below 30,000, say 28,000, I think that's something that reducing or not including the cost of the land, and then we get the housing for something like 27,000 per square meter. Now, you can see the type of things which we are providing, the finishes that we are giving, the kind of amenities that we are allowing, not high end, but to fit the specific group of people whom we are targeting. So the area of collaboration, get as low as we can in terms of construction and provide better than whatever is existing. Yeah.
Thank you. Thank you, Daniel. And unfortunately, Etta, Beryl, and Daniel, I must bring this session to an end, noting the promise we had made to all the participants to attend to the Q&A, to the questions that have come through. But my request would be still remain, because we need to react to all these questions that have come through, for the benefit of everybody who's attended this session. And now, ladies and gentlemen, I would want to request my colleague, Alan, to guide us through the Q&A session, so that then we can react to quite a number of the queries coming through in the interest of time. Alan?
Yeah, thanks a lot, Patrick, and the fireside participants. That was a very insightful session. So we have about 20 minutes to respond to questions. We'll do our best to respond to as many questions as possible. Thank you for the engagement. It's been very useful for us, and we're picking up areas that we can even refine this body of work. So what I've done, I've categorized the questions to the ones that would go to the QS, the architect, and the engineer. And then there are some that will tackle as the financial feasibility team. And I'll be asking them, and then we'll just tackle them in that manner. So I'll start by Nicole. I'll just mention the question, and then you can respond to them after. So from Michael, there's a question about the efficiency percentage of the block designs. To just see what that gross built-up area and gross double area efficiency would be. There's a question regarding whether there's any consideration for parking within the design. And then there's a question around what setbacks were given for the block typologies, bearing in mind for protecting future daylight. I think that also speaks to the just general setbacks. Then for Engineer Brian, I think one of them that the two was the proposed width of the walls. are some wider or thinner given the load bearing capacity. There's also a question regarding whether you did any considerations for earthquake or seismic activity within Nairobi. And then there's a question regarding how much care or technical supervision would be required to undertake this kind of structural design, and what flexibility would be there for the developers. There's also a question regarding structural options that were considered for twist blocks, so that's a start-summer blocks, whether this has been simulated. I think we can start with those two before we go to the Q&A, so Nicole, you can jump in.
Okay. Thank you, Alan. As for the first question about efficiency,
Yeah.
I'm assuming you mean the built up area versus what is left.
Yeah.
So for the first typology, we have about 2,500 gross building area, which is, I mean, for the first, okay, between all three, we have about 2,500 to 2,800 gross building area, so which should come to about maybe 60%. I'm not wrong. Sorry. So when we're designing, it was a hypothetical site because they were still doing feasibility studies on the areas for building. But yeah, we'll come with about 60%. As for the question on parking consideration, it had come up when we're designing. So the target audience of this construction, we were told it's the average user earns about 500 a day. So what we considered was parking for motorcycles and bicycles. So what was allowed, which ties into the setback question, we allowed at the front, we allowed about 4 meters from the building. So this would allow for the parking of the vehicles mentioned. But then also from the building with windows, we did a minimum of 2.4 meters from the setback. So that is what is allowed on the building code currently. So that was those were some of the considerations that we were making.
It's no problem. Yeah, so engineer, we can go to you.
Yes, on the first question, talking about the proposed width of the walls. Okay, this is normally based on the structural design. And in the conventional setup, normally the typical width then will be between 8-inch and 9-inch. So in this particular scenario, I assumed a wall thickness of 8-inch. And this wall thickness was spread throughout the building frame, which is the load-bearing masonry. So with that, of course, from the technical aspect, you do your design calculations based on the EU Code of Standards, which is the preferred code currently in Kenya. And based on that, you look at how it performs in terms of its strength and also the dimensions. The dimensions meaning the cross sections. So in those aspects, this is what we factor in on the calculations, and then we check it against the overall building width of the structure until the foundation. So if it's below the design limit, then yes, it's satisfactory. If it's not, then that is where now the structural engineer might come to the architect and maybe propose some design adjustments, just to balance the equation. Number two, how is this different in different earthquake zones? Okay, so basically, when I was doing my design, I assumed based on the seismic zoning map, which is in Kenya, which the one which I used wasn't up to date, although by the figures that I saw, Nairobi was lying under a Richter scale of a magnitude of 5, if I can remember very well. So with the magnitude of 5, that I believe, because we've had previous experiences where we've had tremors in experience here in Nairobi, and the tremors which were actually measured as per the Richter scale were coming to a magnitude of 4. So 4 or 5, that basically balances the equation somehow. And given the fact that that has occurred before, and we've never had any incidents where the buildings have collapsed, whether it be concrete frame or load bearing, then I can say Nairobi is far much away from the epicenter, which is at the Rift Valley region. Number three, we talked about the quality control of these construction materials, particularly the concrete mix. There's also the load-bearing masonry and the number of size and openings. So if I start with the concrete mix, basically the quality control that is taken measure on is assessing the characteristic compressive strength. Sorry, I'm being a bit technical, but basically this is how much strength can this concrete achieve as per the design which was done previously by the engineer. So of course, when I'm doing my design, I have to factor in a particular strength of concrete, which of course I have to balance the economic benefits and also the sufficiency in terms of structural integrity. So this basically what happens is whenever we embark on site during construction, normally what happens is you tell the MC to come up with a mixed design which will achieve that concrete class 25. If the contractor is not able to, this is where now we recommend the contractor to obtain a premix. If he or she cannot achieve it on site, this is where now we recommend the premix. And of course, with the premix, when the day of concrete casting comes, the quality control agent from the premix company has to be present and just assess things like, there are some various tests which have to be done on the concrete before pouring. And some of these tests are like the slum test, just to check the workability of the concrete, and also just, making sure the concrete hasn't lost its water content, the water cement ratio. So from that, of course, once they assess that, they create concrete samples or other concrete cubes. And then from these concrete cubes, they create like at least 3 or 4 minimum. So from there, now these concrete samples after 7 days, they'll be taken to a materials testing lab and just assessed in terms of their strength, which of course there are certain criteria as the structural engineers have in place to check if we're actually as per the design intent. Number 3, no, that was the concrete mix. So number 2, for the load-bearing masonry, quality control also has to be focused on, and one of the quality controls is again the testing. Some of these testings include the crushing strength. So the crushing strength, again, this has already been predetermined during the design phase. And the crushing strength, of course, when the MC or the developer has identified a particular supplier, what normally we recommend us as structural engineers is for them to give us samples. So from these samples, this is where now we take them to the testing lab and then assess how strong they are. So crushing strength is number 1. Number 2 is also the water absorption rate. So how much, for example, during the rainy seasons, how much will it affect the durability of this particular masonry block? That also has to be assessed, and which, of course, has been predetermined during the design phase of the structure. Number 3, and finally, is the bulk density of the load-bearing masonry. So basically, the bulk density correlates with the weight of these blocks. So, you also don't want a very heavy material, or rather, a very heavy material to the extent where if it's channeling all that weight to the foundation, we don't have incidents where there are differential settlements or, basically the foundation has failed in terms of punching. So those are some of the criteria and factors that we structural engineers have to put in place when it comes to the load-bearing masonry. Last but not least, the number of size of openings. Of course, this correlates with the design of the architect. In these typologies that we presented, if you look at the spans, or rather just the widths and the heights of the openings, they're actually not that big. And the fact that we introduced the concrete ring beams, which I explained earlier, which have dimensions of 300 by 200 millimeters wide. Basically, some of the things that you need to look at is how far is this opening actually widening to the point where now this concrete ring beam will start developing an effect known as sagging. And with the effect of sagging, of course, it has an effect on the window frames and the door frames, where you find incidences where now they start crashing to the point now the functionality of the particular unit has been affected. So those are some of the factors that we as structural engineers also have to put into account. And of course, if we find that the opening is actually wider, this is where now we perhaps increase the depth of the concrete ring beams, or we increase the amount of steel reinforcement that goes into it. So it's a matter of balancing the equation in terms of the cost-benefit analysis. There was the question of twist blocks in relation, if I'm not wrong.
Yeah.
So that one wasn't actually put in consideration. However, the first design meeting we had the suppliers who deal with twist block systems. It's actually a very interesting concept where we even went further and visited their workshops and saw how actually the twist block systems are made and how the quality control is being assessed. And from my structural point of view, twist blocks are actually far much stronger by far than masonry blocks. Maybe the only caveat might be that the twist blocks are made of concrete, while masonry blocks are made of natural material. So there's a bit of compromise you can, factor in there as per, the design intent and also how much the developer or the design team would want. So yeah, thank you.
Yeah, thanks a lot, engineer, for those responses. So for the quality survey, Jeff, I think the two questions that were raised was whether all the cost estimates included or excluded VAT. And then do the costs have contingencies to cover power, water connections, and even maybe a transformer if required. Then back to Nicole, the quick question there is, what is the floor to ceiling height that was granted? So as you're responding, as a prior response to those questions, I will take a couple of questions that were directed to us. So I think Daphne asked, whether there were also design considerations for women, children, and caregivers, because sometimes that's left in the exam planning phase. I can take that, and then Nicole can also answer it. In terms of whether there's a gender responsive approach in this development. So it's really Nicole can take that question. Alex asked whether there's also been any attempt to rate the design on green building tool and what the preliminary results were. So Alex, you have not been able to take this through. I think maybe the IFC Edge tool would be the most robust tool, but I think it's a fantastic suggestion to be able to key in the design considerations and see what the outputs would be. So we haven't done it at this stage, but we will definitely do it. There's also a comment from Sam Okello regarding the land costs being about 25-30%, and we completely agree with you. I think the balance that we're trying to cater for, again, with low-income earners is just having parcels of land that are close to employment sort of demand areas. So you get to see that sometimes that cost of land is quite high. But if you look at the national cost benchmark or development cost benchmark we did, it should be about 15 to 20%. So yeah, it would be great if we could partner with public institutions to be able to subsidize that cost as a joint venture investment into this particular project. Then Tafsai has asked an interesting question around the cost of the unit vis-a-vis the target income levels of the product. So what is interesting is if you look at the costs that we have projected, I think they range from 600,000 all the way to 900,000. And that is actually perhaps the cheapest that we've seen within this space. Even when you look at the affordable housing projects that are being done by the government, there is anything that is coming close to this kind of cost. They're all more expensive than this. And the point that has been raised is that these costs are quite high if they're targeting low-income earners and they're able to own them. But the point we're trying to put across again, as Sita has mentioned in the chat, is that we're focusing more on dignified rental. Because when it comes to home ownership, then you get into the sort of quagmire of the tools available to finance the long-term ownership for low-income earners. But I will allow QS Jeff to respond to the questions, and then we can go to Nicole for the last one.
Okay, thank you. I'll go straight to the questions that have been raised. One is on the contingency. The normal market practice, usually people do 5 to maximum of 10%, but usually 5 is the most widespread used contingency in projects. But here's the kicker on our project. We have detailed the design, and therefore we have broken down the cost in a way that we tend to understand where each and every cost is allocated, therefore minimizing the risk of unknowns. So if we are to work with this based on the typologies that have been shared, we saw a reason why we could lower the contingency, because you remember this is not a cost allocated directly to the project, but just in case something happens. So being that we work on the upper limits of, like, you remember the engineer mentioned that based on the geotech, probably within the market you'll do 1.2 meters, but in our projection we work with 2 meter depth. So thereby reducing the provision for contingency. Contingencies could be higher when you've not really detailed the design, or you really do not really understand the full scope. Then it will be better to have a larger contingency so that as things come up, that you utilize them. So that explains why we saw the need to really lower these to, we provision for a 3% provision of the project cost. On to the next question. There was a question on how we distributed the cost to achieve the cost of every unit. For these, we worked out with the project areas, whereby we have the total area of the units, and then we came up with the total cost of the substructural and also the frame structure element, and also the walling. So from that, then we took the gross area of a single unit against the total area and multiplied by the cost, so that the cost is equitably allocated to each and every unit. That's how we distributed our cost for elements that are not directly to the units, but for internal, the finishes, then they are direct to units, doors, and windows. Thank you. Then the last one is on cost. We developed our cost from actual costs expended. So material costs include VAT, because when you purchase these materials, then you'll pay for that, but labor costs are exclusive. Thank you.
Jeff, Nicole.
The question of the floor to ceiling height, we did 2850, that's 2.85 floor to ceiling, and then out the slab takes 150, which also ties in with the question of natural lighting for the openings. We allowed for 1800 high openings, which in our field, the rule of thumb is that the depth allowed for natural light is twice the height of the windows. So we were accommodating about 3.6 meters in from one side, and then the other opening on the other side. So we were getting maximum natural light in the units. And then the question about gender consideration on the shared spaces. So I understand the security risk or the safety risk for each gender. What we did was, where we located the shared facilities were right at the highest traffic locations. That means like the Dobie area is located right at the entrance, and then the shared washrooms are located right at the circulation core. So that means this is where this area certainly gets the highest traffic. So this would mean the people actually just surveilling themselves, like as they walk up and down the stairs. So aside from separating the bathroom based on gender, we had discussions on whether to also include children's bathrooms, but then became another feasibility issue. So for this, what we just did was just to separate the bathrooms and make them have 1.1 meter wide openings, not doors, not lockable, so that, I mean, it doesn't become another security risk. So it's just openings that allow people to walk in and out safely, but in a concealed manner, and also just have people walking up and down the stairs become the surveillance of this area. So it's basically safer, if I may say so. Yeah, unless Alan has...
Yeah, I think that's true. So Nicola's answered it perfectly. We had those considerations for gender, and I think from an operations perspective, it then became a bit challenging to see how one can be able to separate the genders, because even when you look at the existing shared facilities in pipeline, most of them are not like gendered toilets. But yeah, those considerations were given, but what we developed, I think, was sort of the best case that we could end up with. The final question that I'll take is from Maureen in terms of whether we catered for socioeconomic aspects for the target communities. So like having mixed use, commercial, mixed use on the ground level, like commercial. So for this particular design, we didn't do that in the final design, but I think at some point we had considered having the mixed use elements so that you can have shops at the very bottom floor, but we opted to just go with the residential use all across and ring fence the project to just residential. But we had considered it, but we didn't make it to the final sort of design. So I think we'll wrap up the Q&A session at this point. I have posted the email address for Patrick and myself in case there are any additional questions or engagements that would be needed to be had, so that we are free to continue engaging with this subject matter. And for all the questions that we might not have addressed, we make sure we send out a circular with the answers and comments around it. So I'll hand it over back to Patrick to give us the closing shot and close the webinar for us.
Thank you, Alan, and thank you, everybody, for this engagement we've just had. Again, for the professionals, thank you to the professional team for reacting to these queries and shedding light where it needed to. And as we wind up, probably just to get quick parting thoughts from the professional team, starting with Grasp. Any parting thoughts as we end?
So my parting shot is just that this sort of engagement is highly encouraged in our profession, so that information is shared all around, and then we will be able to build better, know better. Yeah. That's it.
Thank you. From the engineer, any parting thoughts?
Yeah, mine would be, I believe we're in the right track, and when you're talking about affordability and sustainability, I think the first point of initiative of the initiative is to ask questions. How can we actually achieve this? How can this become a reality? So the fact that we've already started getting the ball rolling, I believe we're actually heading in the right direction. And even as structural engineers, we've very much become highly encouraged, even in terms of, yes, we might be used to design structures the conventional way, but that aspect of thinking outside the box also challenges us and also opens up our minds for the greater good, of course, for the stakeholders and the community at large. Thank you.
Thank you. From Getso, any parting thoughts?
Okay, thank you. For us, we appreciate the conversation. It's a conversation that is happening at the national level in the public sector. We also players in the private sector, and we appreciate it for the opportunity, and also for everyone who participated in this. So I believe in the right track of really looking to offer housing to the low-income earners, and looking at the costs and the estimates. It's quite interesting, and be quite interesting to explore this to the future. Thank you.
Thank you. Kaf, any parting thoughts?
I think for us, it's been a very interesting session. And thanks to the FSDK team and to Sita and Patrick and Lucy for sort of driving the conversation beyond just having sort of textbook analysis on affordability, and moving now to a point where we could actually possibly implement an affordable housing project. So we are really looking forward to being able to actualize this with the different partners that we'll be able to identify. And I think it's been very exciting to be at this point.
Thank you. Daniel, Liv, any parting thoughts as we wind up? Would have dropped off, but Etta, if you can hear me, any parting thoughts?
I think it's important that we're having this lively chat on the chat box. People are looking at the detail, people are getting technical, people are calculating, and that's where we need to be. My hope is that this keeps going and we can eventually get to some agreed on typologies that even the private sector can adopt and pilot in some of their projects. So I'm really looking forward to it. I think both the private sector, when I talk about private sector, is both developers, but also landowners. Landowners are one of the major players in the supply of this kind of housing. If they are encouraged and they're not afraid, so I think that's where we need to sort of get to. Everyone with speculative land, everyone with development potential can begin to participate in the supply of dignified urban housing.
Thank you, Etta. Beryl?
Thank you very much, and very interesting questions and feedback to those questions. I think parting short, it's quite key that during this time, as I've stated, that we are discussing this. It's very central to the government priorities, how we shape this discussion, how we establish our role and responsibility, and how we agree on what mechanism to de-risk this sector so that it can be successful. We already are agreeing on what is the supply, what are the demands that are required, and the inputs, and how we really align that. And most importantly, how we achieve it in a manner that is co-created, that is participatory with communities. It's very informative technical input, and we will take it to our own practice as well. And we are happy to engage and collaborate moving forward. Thank you very much. Thank you for calling us to share the platform today. Appreciate it.
Thank you. Thank you, everybody. And from FSD Kenya, we sincerely thank you all for your time, for your insights and participation. And our key observation is that with urban populations on the rise and space becoming increasingly scarce, densifying low-income housing will probably be the only essential option to go by. And as we continue to provide housing for the low-income earners, it will become important to find the optimal balance between structural integrity, cost efficiency, scalability, and financial uptake to drive affordable housing to more and more people in the communities that we serve. And as we conclude, we sincerely thank the professional team, that is GRASP Design, EULA Engineering and Construction, GEPSO Consultants, for the invaluable input into the construction work that we've just witnessed, CAF, the Center for Affordable Housing, for coordinating this work, and the Livelihood Impact Fund, REAL and UN Habitat, for the additional insights that you've actually brought into this session. For the audience, we are happy to answer any further questions you may have, and these can be submitted through the emails that have been pasted on the chat, and we'll be happy to react to this even as we engage further on the discussion that we've had today. And until next time, thank you and bye for now.
Thank you.
Thank you very much. Cheers, everyone.
Thank you.